Okay, so we are going to learn the product rule and the quotient rule. So for right now, the product rule is going to seem optional because it will be, but eventually once we learn more functions, it will actually be mandatory. So learning the rule right now will actually help. So the product rule is if you have two separate functions that are being multiplied. We are allowed to do a different product rule with more than two functions, but that is not discussed in Calc 1 or even in Calc 2. So the way it works is you take the second function times the derivative of the first, and you add the first function times the derivative of the second. That is a lot to memorize. So I did not make this up. We have this little saying. It's 1d2 plus 2d1. And it really just kind of flows. It's not the order that this is written in, but with addition, it could be reversible. So what I'm going to show you is how to do a derivative with a product rule when it's optional, and then without a product rule. So let's say I was doing my first function on part A without a product rule. Well, in order to do that, we're actually going to have to clean up the original. So we would multiply, we get 6x cubed minus 10x squared minus 12x squared plus 20x. And then I would combine like terms because that makes your derivative easier. Okay, so these are all just powers of x, so we're going to use the power rule. So on our derivative, we're going to bring the power down by multiplying and subtract 1. Bring the power down, subtract 1, and bring that power down. And that power would go away. Okay, so this would be our derivative, and it's fine. If we use the product rule, the way that works is we have a different thinking. So we are going to think of this as 1 and this as 2. So on our derivative, we can start. We don't have to simplify anything first. So our derivative is 1, so 2x squared minus 4. And then I have to take the derivative of 3x minus 5. So remember, bring your power down to get 3, subtract 1, that x goes away. So this is 1 d2. And then the 5 goes to 0. Plus, we've got 2. And then the derivative of 1, that's going to be a power rule. So we'll bring that. So this is 1 d2 plus 2, and then d1. So we're going to bring multiply down. So 4, subtract 1, and then bring this power down, subtract 1. Okay? Now, we can simplify this derivative. So I need to distribute the 3, and then I need to multiply this out. So 12x squared minus 12x minus 20x and plus 20. And we will combine like terms. So this and this. I've got this, this, and this. And this one. And so you see, we get the same answer. They are completely different strategies though. Okay. So you get to decide which one you like. Honestly, if it's going to be optional, I would probably avoid the product rule. All right, so let's do part B. So on part B, because I know it's going to be more of this, I'm going to actually do it with the product rule or without. It's a choice. So let's just say I recognize it as a product and I want to use that. So this is going to be 1, this is going to be 2. So I'll write it down here. So I get y prime is equal to 1. On an AP test, they will never specify which rule you have to use. This question would not be given if they wanted you to use a product rule though, okay? So 1 and then d2, so that derivative would be 2x, 1 d2, and then 2, and this one's not actually terrible to multiply out, and then d1 is another power rule, and then minus 1. All right, so we are going to have to multiply this out. So y prime is equal to distribute. I get 2x cubed, and it's really easy to make a little error, okay? I'm going to try to have the answers on your homework so you can match it up because this is pretty extensive math work, but that's also how you're going to get stronger mathematically. And then combine like terms. So let's see, I always like to cross them out. So 2 and 2 is 4. I've got -2, -1. I always lose track, so I think that's a minus. So minus 2x plus 4x, and then minus 2. Okay. Not terrible. It is pretty time consuming, so I think I only have a few for you to practice. When I want you to use the product rule, we will make it mandatory, and that's coming up soon. All right, the quotient rule. So the quotient rule is just like it sounds. It's when you have two functions that are written as a quotient, okay? And they can't be factored and reduced. If you can factor and reduce, you definitely want to, okay? Reduce first, if possible. Because honestly, then that avoids the quotient rule, and it's not like the quotient rule is going to be a time saver. It's not. Keep in mind, the only alternative to the quotient rule is to actually do that definition of a derivative the long way. So this is the shortcut already. Now, this thing is a little harder to memorize, but it really does flow. So the way it's written is I think of the bottom as low and the top is high. So it's low d high minus high d low all over low squared. And it's kind of like yodeling. After you say it like 3 times, you really will memorize this, okay? So I don't memorize all that notation. That is just a lot. Because this is in low squared, you're going to leave your denominator in factored form. So I'm going to put a little hint here. So leave in factored form. And in the numerator, you are going to simplify that, okay? And a lot of times these will not factor any further. That's not the goal. Okay? All right, so let's look at number 1. So I think of this as together, low, and this is high. So our derivative is low, and make sure you use your parentheses. D high, remember the derivative of 5 is 0, minus high, and then d low, the derivative of 3x is 3, and the 2 goes to nothing. I try not to write those zeros so it doesn't look any more confusing. All over low squared. Well, what's nice on this one is that cancels out. So I'm left with -15 over this quantity. And you want to leave everything in factored form. That is the best. All right, let's try another one. So see, these don't factor. They're not supposed to. So low and high. So our derivative, I'm going to use F to get used to our notation, is low, and then d high. And I know I might do my derivatives a little bit faster than you, but I promise you'll catch up once you get more practice. Minus high, and then d low, that derivative, bring down the 1, multiply, and the derivative of 1 goes to nothing. All over low squared. Okay, because this is being subtracted, we cannot cancel. So we're going to change colors and we're going to distribute. So our derivative is 8x plus 4. And then this negative right here, I put it on with that 2 because then I can distribute a -2 all in one step. All right, so we get -8x and then plus 6. It's really always the signs that are going to get you. Okay, and our derivative, it is just a coincidence that these cancel out. That does not always happen. So, okay, and that's our derivative. All right, our last problem. We've got y, so y prime. I've got low. Keep in mind that's like a -1, so d high, I'm going to bring that power down. and subtract 1, it gets rid of my x. Low d high minus high. Is there any room? And then we're going to do it sideways. 2x plus 4 all over. And this doesn't factor. That's not really the goal. Okay, most of these will not reduce first. Eventually, we're going to mix them all together. So then that's when I say, hey, if you can reduce, please do so. So our derivative, well, we're going to distribute the -1. I know I don't have to put the 1 there. I just like to. And 2 negatives, let me change colors, will make this a positive and a positive. So I'm going to distribute a positive x. Once again, these are long. I don't have a lot for you to practice. Once you get the idea, it should make sense. So we are going to combine like terms. I get x squared. Once again, that's coincidence. Those cancel out. And there we go. Okay. Now, what we're going to do is compare. So the quotient rule, it is long. I don't know if it scares you, but I do try to avoid it if I can, because there's just quicker ways to do some of the problems if they're hiding it. So what we want to do is we want to look at some of those scenarios now that we're learning more techniques, okay? If you want to use the quotient rule when it's set up as a quotient, it will always work. There just might be further reducing, okay? These would be multiple choice questions on an AP exam. I, on my quizzes, like to see these problems, but let's say, I'm going to skip this for a second. Let's say I did 1 over x squared as the quotient rule. Let's just say I wasn't thinking and I was like, oh, there's a quotient, let's do the quotient rule. So our derivative is going to be low d high minus high and then d low. So low d high, high d low. And then it's all over low squared. So we're going to clean that up. That goes to nothing. I get -2x. Power to a power, remember you multiply. And I can reduce both numerator and denominator by x. Okay, that's a 3. So that's not terrible. No. Now, let's say I remembered, I was like, ooh, there's no variable on top, so I bet I can rewrite that as a negative power, okay? And then I can just do the power rule. So I bring down my power, and then we subtract 1. And we never leave negative exponents. And I got the same answer. Oops. Okay, so it's really a choice. Same thing with here. So let's say I do a quotient rule. Let's do black. So I get y prime is low, and then d high, we got a power rule, another power rule, nothing, minus high, and then d low is 2x, all over low squared. And I do write all that out. I know I could clean that up, but I don't, just because there's a lot of other things to keep track of. So we're going to distribute the x squared. I'm going to make this negative over here. It's enough work. I like to keep track of that. So -2x times x squared, -2x times -3x, and then times 1. All over. Now I'll simplify it. And then we want to combine like terms. Well, that's kind of nice. Add these together. And really, this looks like a good answer, but all the terms have an x I can take out. That's reducing. Okay? That's some good math there. Now, separating, what they mean by that is when you have one term in a denominator, you're allowed to put these over the denominator. It would not work if this was reversed. If you if you have more terms on the bottom than you do on top with adding and subtracting, you're not allowed to split those up mathematically. It doesn't work. So this is still my original. So you could do this in your head. You don't have to show that. So our original, if I reduce, will be 1. Reduce this, I get 3 over x, and that's already reduced. Okay? So if I want to take this derivative, I actually have powers. So I'm going to rewrite this, and notice it's still the original, as x to the negative first plus x to the negative second. Does that make sense? So then when we go to take our derivative, notice, see, I changed notation. Ooh, I don't like that. Let's go back to pink. Well, 1 goes to 0. I'm going to bring that power down and subtract 1. Bring that power down and subtract 1. So then if we write this without negative exponents, now these don't look the same, but depending on the multiple choice, you really have to be flexible. Sometimes they put them together, sometimes they don't. So if I did want to put these together, I would have to get a common denominator by multiplying by x. And then you can see we'd have x cubed, and I'd have 3x minus 2 on top. So generally, if it's multiple choice, you have to be flexible. So this is also a good review. I don't think that one answer is better than the other or one strategy is better than the other. It was about the same amount of work. It's just whatever you see first, okay? All right, so now we are going to try to get to problems that it's mandatory. All right, and just those 4. So I'm going to give you a chart, and the way it works is these are x values, and then these are y values. So on part A, if we want our derivative, well, we can use just our general formulas. So I've got 4, and it's being multiplied, so then I take the derivative. Same thing here, those are being multiplied, so the 1/2 stays, and I take the derivative. And the derivative of 1 goes to 0. So then I can plug in x equals 3. That's what that notation is. So I want 4 times g prime of 3 minus 1/2 times h prime of 3. So by substitution, here's g prime. I've got negative 2. So 4 times negative 2. And then h prime of 3 is pi. Now, there's not much we can do, but I can say it's negative 8 minus 1/2 pi. We don't use decimals. This would be a non-calculator question. All right, let's try B. So B, what you notice is that's a product. So you're going to have to do a product rule. This is 1 and h is 2. That addition is separate. So our derivative is 1 and then d2 plus 2 d1. Okay. The derivative of x, remember it's like a power rule. We bring the power down, take away the power of x. So then we can substitute 3. So I know you can do this without writing it. I'm fine with that too. I'm just writing it all out so everything is very clear. So g of 3 is 4, h prime of 3, h of 3, and g prime of 3. So what do we get? 4 pi minus 6 plus 1, which is 4 pi minus 5. That's f prime of 3. All right, on C, you can keep the 2 or you could put the 1/2 out in front. I'm just going to keep the 2. So our derivative is low d high minus high. And then d low, remember that 2 is being multiplied, so it stays multiplied. And high d low all over low squared. So that will square the 2 also, okay? So we are going to do some substituting. I'm just going to write it up here. Actually, I might have some. There we go. So I get 2. What's h? H of 3 is 3. G prime of 3 is negative 2. G of 3 is 4 times the 2 times h prime is pi. And then h of x is 3. So I get 2 times 3 times negative 2 is negative 12. 4 times 2 is 8 times pi. All over, what's that? 6. 6 squared is 36. Now, I can reduce all terms by 4, so I would. And sometimes we'll actually factor out a negative 4. So if I put my negative in front, that would be like negative 12 plus 8 pi. And then I can divide 4 by all terms. So I get 3 plus 2 pi over 9. They like to keep the leading number not negative. So, okay. All right, the last one. I know it's a lot. Our derivative is low. And then d high. So d high, they're being subtracted, so I take them separately. So g minus h, low d high, minus high, and then d low. I'm abbreviating because I'm running out of room. All over low squared. Okay, so what do we got? G is 4. G prime is negative 2 minus what's h prime? Pi. Minus G h times G prime all over low squared. So G squared. Okay, so I'm going to put it over here. Negative 8 minus 4 pi. I've got 2 negatives, so I'm going to distribute. What is that? 4 minus 3 is 1. 1 times 2 is 2. All over 16. So what do I get? Negative 8 plus 2 is negative 6 minus 4 pi all over 16. And that reduces. So I'm going to take the negative out. We get 6 plus 4 pi over 16 and reduce by 2. So I'm going to write it down here. Sorry. Negative 3 plus 2 pi all over 8. Ooh, that was a long one. Okay, I've taken up a lot of time, but hopefully I made that easier for you. Good luck.